Picture this. You type a few prompts into an AI builder, grab a coffee, and by the time you sit back down, you have a whole app. Login screen, database, admin dashboard, maybe even billing. It looks gorgeous. It works. You ship it. And somewhere right now, a stranger is probing that same app in a browser tab, trying to turn your shiny demo into their personal data vault. The scary part is with most vibe-coded apps, they do not need elite hacker skills. They just need to know where to look. Here is the punchline nobody wants to hear. That app you built in hours with AI could be hacked in minutes. Not because you are careless, but because the entire vibe coding ecosystem is optimized for screenshots, not security. Platforms promise, describe the vibe, ship the feature, we handle the boring stuff. But the boring stuff is input validation, permission checks, key rotation, rate limits. In a minute, I will show you how one major AI platform let attackers just skip the login screen entirely. Let us start with vibe coding itself. Vibe coding treats software like a mood board. You describe the feel, pick a template, and trust the platform to wire everything together. If the happy path works and the demo looks slick, you call it done. But underneath that glossy user interface, the code is often a Frankenstein of copy-pasted patterns from public repos, many of them insecure. And here is the pattern break. On places like GitHub, the average code the models learn from is not senior-level security. It is beginner mistakes, repeated at scale. Security reviews are already sounding the alarm. Industry audits of AI-assisted and low-code apps keep finding the same thing. Roughly 1 in 5 projects has serious security or configuration flaws, especially around authentication and cryptography. That is not a rounding error. That is 20% of apps quietly shipping with doors unlocked. And this is not just big startups. Solo designers, indie devs, tiny agencies are deploying vibe-coded apps that hold real customer data, payment details, and OAuth tokens. This changes who gets breached next. And attackers have noticed. Researchers have used the exact same AI platforms to build full scam operations. Think pixel-perfect fake Microsoft login pages hosted on legit-looking app domains, feeding stolen credentials into a polished dashboard. AI is now just as good at vibe hacking as it is at vibe coding. The core mistake is trust. Builders assume the platform is handling security behind the scenes. In reality, most of these tools optimize for speed to demo, not for threat models, not for compliance, not for adversaries. In a moment, we will walk through how one platform fell apart under basic testing. So what does a real AI platform hack look like? In one major case, security researchers did not need a fancy zero-day. They just ignored the login form and talked directly to the backend API. The platform trusted a single header and a project identifier instead of verifying real sessions or signed tokens. Change the header, guess the project ID, and suddenly you could impersonate users, including admins. No multi-factor auth, no robust session management, just, are you sending the right magic string? Once past that flimsy gate, it got worse. The platform treated resources as public by default, hiding them behind what were basically secret-looking URLs. But those URLs followed predictable patterns. Testers generated thousands of candidate links and walked straight into other people's projects. Some of those links exposed raw JSON configs with database URLs, environment variables, and third-party API keys. In a few cases, one leaked preview link meant source code, build logs, and production credentials all in a single hit. This is not elite hacking. This is tutorial-level capture the flag, accidentally deployed to production. And the AI-generated backends amplified the blast radius. Models happily scaffolded routes like /admin/users and /admin/settings. The front end added pretty role checks in React or Vue, but the server never enforced them. If you could hit the endpoint, the backend assumed you belonged there. Attackers used this to downgrade roles, upgrade themselves, pull full customer lists, even trigger data wipes. Remember that one in 5 stat. Once researchers found one misconfigured route in a vibe-coded project, they usually found a dozen more. Now, here is the part that might hurt a little. Your private app is probably public. Many builders rely on security by obscurity. An unlisted URL, a hidden admin link, a preview domain that is not linked anywhere. On the open internet, that is not a permission system. It is just a guessable string that search engines, link scanners, and board attackers brute force all day. Researchers keep finding so-called private dashboards indexed by Google or discoverable with a simple site search and the word admin. Real security starts with role-based access control, not vibes. Every user gets a role, like user, support, admin, or billing only, and the backend checks that role on every single request that touches data or configuration. Vibe-coded apps often stop at is logged in equals true and call it a day. But your browser can lie. A React app that hides an admin button is meaningless if the /AP/admin/users endpoint only checks for a session cookie. In a minute, I will give you a brutal checklist you can run against your own app tonight. Here is that checklist. Log out completely and try hitting every admin, internal debug, and API route directly in the browser. Then log in as a normal user and replay any admin API calls you can see in the network tab. Try removing or changing the role claim in your token and see what still works. Turn off JavaScript and visit protected pages. If sensitive data still loads, you have a problem. Any action that works without a strict backend permission check means your so-called private app is already public. But even if your auth is solid, there is another disaster waiting. Secrets. Vibe-coded apps often ship with the crown jewels baked straight into the code. AI assistants will happily paste database passwords, OpenAI keys, Stripe secrets, and JWT secrets right into source files because you never told them not to. Once that repo, or a preview build, or a log snippet goes public, automated bots scrape it within minutes. One leaked key can give attackers full read write access to your data and your wallet. Proper secret handling starts with one simple rule. Secrets live in environment variables or a secrets manager, not in code. Your app should read from process.env or an equivalent, and your config files should be in git ignore. Larger teams should be using tools like Doppler, HashiCorp Vault, Cloud Secrets Managers, or 1Password Automation. And here is your fire drill. Today, search your repos for words like API_key, secret, password, bearer. Check your platform dashboards for visible environment variables and logs. Any key that ever touched public code or screenshots needs to be rotated now before someone else does it for you. And then there's the front door problem. AI tools love scaffolding helpful extras. Admin dashboards, debug consoles, schema explorers, feature flag panels. They often stay online, unlinked from the main UI, but fully accessible to anyone who finds the URL. Security researchers routinely stumble into /admin, /debug, /playground, and /graphql endpoints left wide open. Once inside, an attacker can flip feature flags, dump data, or grab environment variables in a few clicks. They are not picking locks. They are walking through doors you forgot to close. Client-side validation will not save you here. AI-generated frontends love pretty error messages and form constraints, but attackers talk directly to your API with curl Postman or a Python script. Only server-side validation and authorization actually protect your database. Every input needs strict rules. Emails must look like emails. IDS must match known records. File uploads must be limited in type and size. And your storage buckets should be private by default with signed, short-lived URLs for access. A misconfigured S3 or Supabase bucket can leak thousands of invoices, ID scans, or medical reports in one shot. So what do you do if you are already shipping Vibe-coded apps? Step 1, assume you are breached. That does not mean panic. It means design as if someone is already poking at every endpoint. Harden authentication. Implement real role-based access control. Lock down admin, debug, and schema routes behind auth, VPN, or single sign-on. Move secrets into a manager and rotate them. Run automated scans for open endpoints and misconfigured buckets every month. In a moment, I will explain why this is not just a patch, but a culture shift. Because the real future here is not bolt security on at the end. It is devsecops. Development, security, and operations treated as one continuous loop. The same AI that scaffolds your app can also scaffold tests, threat models, and hardening scripts if you ask it the right questions. Instead of build me a dashboard, ask, build me a dashboard with strict role-based access control, server-side validation, and no secrets in code. Treat AI builders as power tools, not guardians. You own authentication, authorization, secret management, and configuration, no matter how friendly the interface looks. Here is the bottom line. Move fast and break things quietly turned into ship first, secure never. That worked when your prototype was a static landing page. It does not work when your minimum viable product holds live payment details, OAuth tokens, and production customer data. AI has made it unbelievably easy to build. It has also made it unbelievably easy to attack. The question is not, can someone hack your AI built app? The question is, how much damage can they do before you even notice they were there? If you are building with AI today, treat this as your emergency checklist and your wake up call. Audit your routes, lock down your roles, evict secrets from code, harden your storage, and start asking your tools for secure patterns, not just pretty ones. If you want a deep dive on how to turn your AI builder into a DevSecOps assistant, tell me in the comments. Make sure you subscribe so you do not miss the next breakdown, because this story is moving faster than most people realize, and the safest apps will belong to the builders who take security as seriously as they take speed.